Okay, in this screencast, what I'd like to do is give us some examples involving areas between curves, things that I think an entering calculus student should know how to do. So I'll start with example 2, because example 1 was in a previous video. Let's find the area enclosed by y equals 4 over x squared, y equals 4x, and y equals x over 2. Let's find that area. Some things are easy. X over 2 looks like this. 4x looks like this. 4 over x squared looks like this. So we're looking for this area. Vertical slices run from blue to red for a while until you get to here, and then vertical slices run from green to red. Slicing horizontally doesn't change the issue. We go from green to blue and then from red to blue. So either way, we've got to split it up into two sub-intervals. So we're going to do an integral from 0 to wherever this is of blue minus red, because we integrate top minus bottom from left to right. And then we're going to do an integral from wherever this is to wherever that is of top minus bottom dx from left to right. So where are those? Well, a little bit of algebra will tell you that green hits blue at x equals 1. And a little bit of algebra will tell you that green hits red when x equals 2. So that's a 1, that's a 1, that's a 2. Now, the fundamental theorem of calculus says we find an antiderivative. Any antiderivative will do. Sub, and subtract. And then we find an antiderivative. Any antiderivative will do. That's a 4. Sub, and subtract. So this part is 2 minus a quarter, and then minus 0. And then this is -2 minus 1 minus -4 minus a fourth. Luckily, videos are pausable, so you can double check those computations. It turns out that the area is 3. Nothing fancy, just setting up the integral, fundamental theorem, substitute, and subtract. If I can do a couple more, I don't want to do too many more. This will be example 3. We're going to find the area between cosine x and cosine 2x as shaded. So to be clear, cosine x looks like this, and cosine 2x looks like this, and I'm interested in this area, which appears to be the integral from 0 to wherever that is of blue minus red dx, top minus bottom from left to right. Where is that? Well, that depends on how good your your trigonometry instructor was in high school. Setting cosine x equal to cosine 2x, this turns out to be 2 pi over 3. If you're in a pinch and you have a calculator, then you graph both curves and you see where they cross. And that turns out to be at about 2 point something, right? probably 2.08, 2.09, something like that. Keep a bunch of decimal places handy because 2 pi over 3 is much more exact. So again, we're looking for an antiderivative so that we can sub, and subtract. The function whose derivative is cosine x, that's sine x. The function whose derivative is cosine 2x is sine 2x, except wait a minute, the derivative of sine 2x is 2 cosine 2x. We don't have a 2 here, so we compensate. We can also do that by u substitution. Nothing here is terribly beyond what Calc 1 should have taught us, and then eventually you end up here, I hope. That's the sort of thing you'd want to contact me about if you weren't confident there. Can I do one of the other kind also before I do any sort of an OYO? So this is x equals y squared minus 9, and this is y equals 1/3 x minus 3. The figure is very not drawn to scale because this is the point 0, -3, but this is the point 27,6. Figure very not drawn to scale. So when we find this area, oh golly, this area, we integrate right minus left from bottom to top, right? Right minus left from bottom to top. Well, the right function is the red function. The red function is not in terms of y. So we've got to solve for x in terms of y. Kick the 3 over, multiply by 3. That's the red curve minus the blue curve, dy. Top, from bottom to top, right minus left. So a little bit of algebra makes things a little bit easier. This is negative y squared plus 3y plus 18 dy. And the fundamental theorem says any antiderivative will do. We substitute the 6, we substitute the -3, we get -72 plus 54 plus 108 minus 9 plus 27/2 minus 54, and that's 243/2, which is very guessable. You were going to guess that anyway. If you're looking for practice, I present a couple of questions to do on your own. We imagine that this is the parabola x squared plus 2, and this is the line 2x plus 5. You may want to take some time on your own and confirm that that area is 32/3. That might be helpful to you. And then you may want to consider this parabola, which has equation x plus 1 is y minus 1 squared, and this line, which has equation x equals 2y. And you may want to confirm that this area also is 32/3. So those are a couple of things for you to do on your own. I hope this is helpful. Welcome to our course.